When describing the quality of our measurements, we would normally use the terms precision and accuracy. First, we talk about precision, which has two definitions. It depends on the context to which it is applied to. If precision is applied to a measuring instrument, it refers to the limit of sensitivity of that instrument. It is the smallest change in the measured quantity that can be detected by the instrument. Take, for example, when we want to take measurements of a length, we can use a meter rule, a vernier caliper, or a micrometer screw gauge. The precision of each of these instruments will be different. The smallest change in length that can be measured by these instruments will be different. For example, the meter rule has a precision of 0.1 centimeter. The vernier caliper has a precision of 0.01 centimeter. The micrometer screw gauge has a precision of 0.01 millimeter, which when changed to centimeter becomes 0.001. The micrometer is the most precise equipment here because it's able to detect the smallest change in length. When precision is applied to our readings, it refers to degree of scattering of readings. Degree of scattering of readings here is closely related to the range of measured values. If the degree of scattering of readings is small, the readings are precise. Conversely, if the degree of scattering of readings is large, the readings are imprecise. As an example, we have two sets of readings here. Each of these set of readings have a scatter or a range to them. When we want to find the range of the readings, we will take the highest value and subtract off the lowest value to get the range. Over here, we see that the first set has the lower range, whereas the second set has the higher range. The set of readings with the lower range is more precise, whereas the set of readings with a higher range is less precise. Now, you may be thinking that this definition of precision is similar to that of random error because both of them talk about degree of scattering of readings. You are correct in thinking so, but do bear in mind that precision is inversely related to random errors. What do I mean by that? Take, for example, if your scatter of readings or the range of your readings has increased, we would say that your precision has decreased, but your random error has increased. Next, we talk about accuracy. Accuracy has two definitions, just like precision. The first definition of accuracy is something you are most familiar with. It talks about how close the reading is to the true value. Now, as an example, consider a length with a true value of 15.5 centimeter. We take measurements of the length and we obtain readings of 15.3 centimeter and 16.5 centimeter. We would say that the reading of 15.3 centimeter would actually be accurate because the difference between that reading and the true value is only 0.2 centimeter. Whereas for the reading of 16.5 centimeter, we would say that it's actually less accurate because the difference between that reading and the true value is larger at 1 centimeter. The second definition of accuracy refers to the percentage uncertainty of a measured quantity. Before we move on, it's important to understand the meanings of these terms. Uncertainty is the range in which a measurement is likely to lie, whereas percentage uncertainty is defined as the uncertainty divided by the reading multiplied by 100%. Now, we will be talking more about these two terms in the following lesson. For the time being, just take the meanings of the terms as the ones that are written here. Percentage uncertainty would depend on the magnitude of the measured quantity or the magnitude of the reading, as well as the instrument uncertainty used. If we have a meter rule with an uncertainty of 0.1 centimeter that is used to measure the dimensions of a book, we measure the length, the thickness, and the width, giving us the readings here and the corresponding percentage uncertainties as this. The smaller percentage uncertainty would indicate higher accuracy. So right now, 0.7% being the smallest percentage uncertainty here will actually be the most accurate, whereas 2% here being the largest percentage uncertainty will actually be the least accurate. Now, lastly, for any given instrument uncertainty, a larger measured dimension produces higher accuracy. If you look back at the definition of percentage uncertainty, you can see that if the reading is larger, the percentage uncertainty would be smaller. Therefore, it will be more accurate. On the other hand, for a given dimension, a smaller instrument uncertainty produces a higher accuracy. Looking at the equation over here, when the uncertainty is smaller, the percentage uncertainty is also smaller. So therefore, this leads us to have a higher accuracy.